Let's talk about SQL injections. SQL injection is a vulnerability, successful exploitation of which enables the adversary to control the queries to a database executed by an application. Just like any other injection, the vulnerability is caused by the fact that user input is passed into a string unprocessed. The strings is then used to execute a command or a query. SQL injection allows the adversary to get control of the logic of SQL query and thus perform a variety of actions, such as accessing initially unavailable data, causing denial of service, performing arbitrary functions. In other words, all actions the database itself allows you to do using SQL queries. So, what is this vulnerability? Assume we have the users table with 3 columns: ID, username, and password. Also, we have some script that allows for getting a user by their identifier, which is passed in get parameter. This ID is taken from get parameter and placed in the SQL query without any processing. In other words, we can call the script, for example, get user by name, and pass the ID parameter equals to 1. And the script returns the username Bob. Pretty simple, isn't it? So, what does the resulting request that will be executed look like? The ID parameter we passed to the SQL query now looks like this. So, you can see the query on the slide. This code is vulnerable to SQL injection because it has no user input filtering or sanitization. The value of get parameter gets into variable as it is. To exploit the vulnerability, the adversary needs to change the ID parameter value so that it contains the SQL code that the adversary wants to execute. In doing so, it is important to make sure that the syntax of SQL query is not violated after injection. Let's have a look at the following example. We have some form of login that requires a username and password. Below, there is a script that executes the query to the database. The username and password are put in the query. During correct operation, the script uses the query to get the record from the user table with specific login and password. If there is no such login, or if the login and password pairs does not match, there will be no such record. Suppose we have passed the Bob value as login and some password. The query will request a record from user table with the value of the login Bob and passed password. Since there is such record, the database will return the required one. If the password is different from the one in the table, the database will not find the Bob record with password of the digest and will return nothing. As a login, let's use the admin name with a quote and comment symbol and see what happens. First, with a single quote, we close the value of the login variable in the query, and then we can write SQL code. The double hyphen in MySQL is a command, and everything that will be written after it will not be executed. As a result, we have received a query that only checks the value of the user login, and the further check is commented and will not be executed. Another case is when we need to get data from different tables. To do this, we can use union operator, which enables us to merge requests. With this operator, we can obtain data from different tables in the database during SQL injection. For example, we have an injection in a query that selects data from tables. With SQL injection, we can read all data in the articles table, but we need to extract data from the user table. To do this, using the union operator, we can combine queries to the articles table with the query to the user table, and then read the data we needed. Let's take a look at how the union operator works. Let's assume that the results of the query execution provide us with 4 columns. The union operator requires that the number of columns in both parts of the query match. Another possibility is when the injection happens inside a function during the execution of which an error occurs. In this case, we can combine different functions in our request and get the data we needed from the error message. If we do not see the result of SQL query operation on the screen, then it's a blind injection. In that case, to obtain the data, we can use sleep operator and build a logical expression, the execution of which will give different delays using the sleep function. For example, if username starts with character A, then we can execute a delay of 10 seconds. By tracking the response time from the server, we can discover this as a data on the server. So, To automate verification, search and exploitation procedures, we can use a tool called SQL map. It can exploit even the most complex injections. In my opinion, it's one of the best tools to search for SQL injection. So, how can we prevent SQL injections? First, use parameterized queries with which all the data in the query will be safely placed. Secondly, use ORM. Third, use the framework functions that are designed specifically to protect against SQL injections. So, let's do some practice.